Jai Hind to all. My name is Dr. Divya Sharma, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. Now, today's video lecture is on TCP/IP protocol. This topic is from Data Communication Network and its code is BEC 062. Now, TCP/IP protocol is a set of networking protocol that allows communication over the internet. And TCP stands for Transmission Control Protocol. It ensures reliable data communication. Means if you are sending data from sender to receiver, you will get this is wired communication and you will get acknowledgement from receiver to sender. So it ensures reliable data transmission. IP stands for Internet Protocol, handles addressing and routing of packets. Now, these are the layers of this TCP/IP protocol. 4 layers are there: application layer, transport layer, internet layer, network access layer, that is also known as link layer or MAC layer. Now, these are the examples of TCP/IP. When you are opening a website, so there is the application layer. First, you have to enter HTTP. So this is an example of application layer. So first you have to enter this HTTP. This application is requesting to open the page, request the page. Now, second layer is transport layer. Its example is TCP, Transmission Control Protocol. It ensures reliable delivery from sending packet or data from sender to receiver. Now, third is internet layer. It routes the request to the server. What is the optimum path if you are sending packet from sender to receiver. Now, fourth layer is network access layer. It is Ethernet or Wi-Fi, means sends data over the physical communication network. Now, this is TCP/IP model, and here this is the OSI model. 7 layers are there in this OSI model. It is already discussed in the previous lecture. Now, here we are discussing TCP/IP model, where you have 4 layers are there. Now, first, when you are comparing this TCP/IP model with OSI model, so physical layer and data link layer are in the OSI model. Now, here in the TCP, there is a layer protocol defined by underlying network host to network. Now, second is network layer in OSI model, and here is a IP internet protocol layer in this TCP/IP model, where you have ICMP, IGMP, these are the examples, and RARP and ARP. So these are your come in the category of this IP layer protocol. Now, third one is this is transport layer. In the case of TCP/IP and in the OSI model, when you are comparing OSI, so this is same for this TCP model. So SCTP, TCP, Transmission Control Protocol, UDP, User Datagram Protocol. So these are the examples of this transport protocol, transport layer. Now, if we are seeing this OSI model, so 3 layers are there: application layer, presentation and session layer. But if we are talking about this TCP/IP model, so there is a single layer, that is application layer, in which you have examples of application, that simple mail transport protocol, SMTP, FTP, HTTP, DNS, SNMP, Telnet. So these are the examples of application layer. Now, if we are talking about these layers of TCP/IP protocol, so these 4 layers are the application layer, transport layer, internet layer, network access layer. So we will discuss each layer with some explanation. Like application layer is provide network services to applications, like example web browsing, email. So these are the applications of application layer. These are the examples of application layer. Examples like HTTP, file transfer protocol, simple mail transfer protocol, domain name server. These are the examples of application layer. Now, the second is transport layer. Transport layer ensures end-to-end communication between 2 nodes or devices. Now, its protocols are TCP and UDP. TCP used for reliable connection oriented service. Now, UDP, User Datagram Protocol, it is fast but connectionless service is there when we are sending data from sender to receiver. Now, the third one is internet layer. It handles logical addressing and routing of the packets, means here optimum path you have to decide. Now, protocol for internet layers is this: internet protocol, this is IP, Internet Protocol version 4, version 5. These are used for addressing and routing. ICMP, this protocol, this example is used for error reporting, example ping command. Now ARP, address resolution protocol, now resolve IP to MAC address. Now the last one is network access layer. This is also known as link layer, and this manages physical data transmission over the network, and its examples are Ethernet, Wi-Fi, point-to-point connection. So these are the layers, these are the description of these 4 layers which are present in TCP IP model. So these are the full forms: SMTP, Simple Mail Transfer Protocol, FTP, File Transfer Protocol, HTTP, Hypertext Transfer Protocol, DNS, Domain Name System, SNMP, Simple Network Management Protocol, Telnet, Teletype Network, SCTP, Stream Control Transmission Protocol, TCP, Transmission Control Protocol, UDP, User Datagram Protocol, ICMP stands for Internet Control Message Protocol, IGMP, Internet Group Management Protocol, RARP stands for Reverse Addressing Resolution Protocol, and ARP stands for Address Resolution Protocol. See, so these are the short full forms of these short forms which are present in the model of TCP IP. Now 4 levels of addressing are there in TCP IP. First one is physical, logical, port and specific address. So these 4 addressing are for each layer of this which are present in model of TCP IP. So this is the relationship of layers and addressing in TCP IP. So these 4 layers are there: physical layer and data link layer you have to take as a single layer, that is physical layer or MAC addressing is provided for these 2 layers. Second is network layer, transport layer and application layer. Now here you can see physical layer is assigned to this physical layer in TCP IP protocol. Second, logical addressing is provided for IP and other protocols in the case of network layer. Port addressing is provided to this transport layer, and specific addressing is provided to this application layer. So these are the addresses are provided to each layer of this in this TCP IP model. Now these are 4 addressing: physical address, logical address, port address, now specific address. So we will discuss all these 4 addressing one by one. Now physical address. So physical address is also known as MAC addressing. It provides unique hardware addressing assigned to a network interface card. Its example, this is a 6-byte address that is assigned to this physical address 00 semicolon then 1A. These are in hexadecimal digits, and this MAC address is of 6-byte addressing. Now here logical address, this is IP address. Now this is unique identifier assigned to a device and on a network for communication, and its example is, this is an example of logical addressing 192.168.1.120. This is a private IP of a computer in a local network. Now third one is port address. This process identifier on a device. Now it identifies a specific service on or application running on a device. Now let it be, we are taking an example for HTTP, means if we are browsing, web browsing we are doing. So here port address is assigned for HTTP is 80. And if we are talking about this HTTPS, this is a secure web browsing. Now here port address is 443. So these are specific port addresses are assigned for this HTTP, HTTPS examples, right? Now specific addressing. Specific addressing is URL, user unique resource line address. Now domain name. Now human readable address mapped to an IP address. And example, let it be we have to open a website of Google. So that is your specific address. We have to open this Google site. So we have to enter this www.google.com. So it is mapped to an IP like 142.250.190.14. So this is the description of all these addressing modes in each layer of this TCP IP model. So now let us take an example. If we are talking about physical address. Now a node with physical address, let it be you have a sender and sender's physical address is 10. You have to send data from sender to receiver. Receiver physical address is 87. So we have to send a frame from sender to receiver with address 10 and receiver's physical address is 87. Now two nodes are connected by a link, means in a bus topology or you can say in a LAN. So we will discuss it in this figure. This is your sender and this is your receiver. And sender's this physical address is 10 and receiver's physical address is 87. When you are sending data from sender to receiver, this is your receiver, its physical address is 87. Now we are sending data, so we are assigning here source address. Source address means sending data, source address is 10, destination address is 87. So we have to send data from source whose physical address is 10, we have to send data to destination address, physical address is here 87. This is trailer, means we have to use this for synchronization, or if you want to add some extra bits there in trailer part, so you can add it. And this is your packet, let it be this is your packet, and you have to send this packet from sender to receiver, and its source address physical address is 10 and you have to send this data to physical address 87. Now two intermediate computers are in the path, means this is a LAN. So here 4 computers are there, this is your sender, this is your receiver, 2 intermediate computers are also there and its physical address is 28 and this third computer physical address is 53. Now when we are sending data from this sender to receiver through a LAN, so first it will check, when your data will check its address is 28, so it is not matching the destination address, so packet will drop out here. So we are sending another data, so it will match with this third computer, so its physical address is 53, again that packet does not match with this same address with this physical address of this computer, so that packet is also dropped out here. Now again we have to send data and it will passes through this LAN and matches with this computer, so its physical address is 87. So here data will get the destination address and data is received at this receiver. So this is an example of physical addressing. Now here most local, how we can assign physical address. So this is 6 byte address or you can say 48 bit. Now a MAC address, media access control address, is a unique identifier assigned to a network interface card and it consists of 12 hexadecimal digits. Hexadecimal digits you all know, 0 to 9 and A to F. So this address should be in this form, in a hexadecimal digit form, 0 to 9 or A to F. Now these digits are grouped in 6 pair and separated by a colon or hyphen. So this is the format of MAC address, how we can assign MAC address to a computer. Now second we are taking this example that a part of an internet with 2 routers connecting 3 LANs, means 2 routers are there in a network and 3 LANs are there connected with these 2 routers. Now each device computer router has a pair of addresses, logical and physical address are there for each connection. Now in this case each computer is connected to only one link and therefore has only one pair of addresses. Now each router however is connected to a 3 networks, only 2 are shown in figure, and so each router has 3 pairs of addressing, one for each connection. Now we can see this structure. Here this is sender, its address is A by 10 and we have to send data from this to receiver part, its address is P by 95. 2 routers are there, router 1 and router 2, and these 2 routers are connected with 3 LANs, LAN 1, LAN 2, LAN 3. Now when we are sending data from this sender, so there is a data. Now these are your upper layer. Now network layer pe we are assigning a port address here, AP, means your address, source address and destination address. So this is source address, this is destination address. So we are assigning here, sorry, not port address, here we are assigning logical address, and this is physical address. So physical layer, so we are assigning physical address here, this is your source address, this is your destination address. So we have to send data from this A to P, and this is logical address. It will not change in the intermediate levels. Its source address is A, so we have to send data which have destination address is P, and logical address is not changed in between these this network. Now this is physical address. We are assigning physical address to this data. Source physical address is 10 and destination is 20. Now we are sending data from this computer, so it will reaches to this router. Now router's source address is F by 20 because its destination address is we are assigning destination as address is 20, so its router's source address is 20. Now here in LAN 2, here data here physical address is logical address same A to P because we have to send data from A to P. Its physical address is 33 and 99. It means 99 is your source address and destination address is 33. So its router, this is router 2, its source address is n by 33 and we have to send data from 33 to 66, and 66 is the source address, destination address of this data. So through this LAN we can send data directly where you have logical address, means logical address is 95, means its receiver 95 is your physical address for this receiver. So we can send data from this sender to receiver successfully. Now from this example we are discussing that logical address remain unchanged. It means A to P, source address is A, logical address, and destination's logical address is P. So that is not changed in the intermediate level, but here physical address, it is changed at each hoop or each node, ensuring proper forwarding within each forwarding of data within each LAN. Now routers update MAC address at every transition between network while preserving IP addresses. So this demonstrates how layered network communication enables devices across different networks to communication efficiently. Now let us take an example of port addressing. First we are discussing physical address, then logical address, then the third one is port addressing. Now two computers are there in a communication. We have to send data from one computer to another computer through a media. Now sending computer is running three processes A, B, C, and receiving computer process J and K. Let it be you have to send process A to J data. So we have to do a communication from A to J. Now this is sender, this is receiver. There are three processes at the sender A, B, C, and I, J, K are a process at this receiver P. Now we are sending data through this application layer. We are assigning port addresses A and J to this data. At this level, transport level layer, we are adding this port addresses A and J because we are processing A process, we are sending process A to J. So we are assigning here port addresses A and J. Now at this network level, we are assigning logical address A to P, means we are sending data from A to P, source address, and this is destination address, and these are logical address. Now we comes to this data link layer. Here we are assigning H2, header is there, and header you can say unique address or physical address we are providing through this data link layer. So now here from where we are sending data through the internet, and data is received at the physical layer of this receiver. Now first here at the data link layer we are adding here physical address. So here we are removing this physical address and we will get data with logical address A and P, and these are a port address A to J and data. Now when we are sending this data, we are receiving this data from network layer to transport layer. So this logical logical address is removed because we are sending data from A to P and it is received at the P destination at the receiver P. So here when we are coming to this transport layer, so A and J are port addresses. So A say J, your port address process is received at this point P, receiver point P. So we are removing this at this level transport layer, we are removing this process port addresses and we will get data at the receiver side, which is at computer P. So this is all about port addressing, how we can do port addressing when we are sending data from sender to receiver. So in the previous slide which was discussed, physical address changes at each hoop and used for local delivery in each network segment. Local IP address remains constant, used for end-to-end communication, and port addressing remain constant, identifies the correct process on the sender and receiver. It means physical address will change from node to node or hoop to hoop, and logical address remains unchanged. So this is a port address. 16-bit address represented by a 1 decimal number. So this is a port address. How we can represent a port address? Now port address representation is 16-bit port address represented in a single decimal number. Example 753. Now this is 16-bit port address. Maximum possible value should be 2 की power 16 minus 1, and it is the range from this up to this 65535. So this is the range of assigning port address to a sender or receive to a packet. Sorry, port address we are assigning at a level of transport layer. Now here port number ranges are also in different categories. Port numbers are divided into 3 categories. First is well-known port, and its range is 0 to 1023, and it is reserved for standard services like HTTP, FTTP, DNS, and its examples like HTTP port number is 80, HTTPS port number is 443, FTP file transfer its port number is 21. So these type of ports are in the category of well-known port, where you have a range 0 to 1023. Now second type is registered port. Its range is 1024 to 49151. Now it is usually used by the companies or application for specific services like Microsoft SQL Server. Its port is 1433. Docker, its port is 2375. Now the third type of port addressing are dynamic or private port. Its range is 49152 to 65535. It means starting range is from 0, means port number range is 0 to 65535, and it is classified into 3 types. First is well-known port, registered port, and the third one is dynamic or private port. Now this dynamic private port used for temporary or private connections. It is assigned dynamically when a client makes a request to a server. Let us take an example. When we are browsing a website, you have to enter, your computer uses a dynamic port to communication with the server. So this is all about types of ports are there. Now the last one is for the application layer, we are assigning a specific address. In networking, a specific address is a user defined address for accessing web sources. Let us take an example. URL, Uniform Resource Locator, is a specific address that can be used to find document on a internet. Now let us take an example. An email address is another example of a specific address. So this is the summary of all these addresses. Logical addresses provide for physical address. Physical addresses provide for physical layer. Logical address is provided for network layer. IP address, then port number. First is physical address, then logical address, then port IP address, then port address. Now logical address identify devices on the internet. Physical address have to deliver data to the correct destination device within a network. Now IP address is identify a machine in an IP network and determine the destination of a port of a data packet, and port number identifies a particular application or a server on a system. Now these are the textbooks you can refer: Foruzen, Starling, Tannenbaum, and references books are BP Lathi, Ajit Pal, and Dimitri. These books you can refer for this topic. Now thank you.